Our second speaker with our challenge is Mark Daniel from Infineon Technologies UK Limited. Mark is a verification engineer who's been at Infineon for 19 years. I think I was personally recruited you 19 years ago as a verification engineer. His engineer is always looking for ways to improve the efficiency of the verification challenge we all face. Over to Mark.
Thanks. Hi, everyone. I finally made it here, slightly late, but got here. Okay, so I'm working in the area of verifying microcontrollers for the automotive industry. So Infineon delivers for all of these sort of applications. So as we move through from engine management to transmissions, and we move into more advanced stuff like advanced driving, it gets more complicated and there's more. The challenge of verification becomes higher, and so as I said, the title is quite long to the presentation, seems to cover lots of topics that will be covered today in today's conference. I want to present what we see as the challenge within hardware verification for microcontrollers. Okay, so this is our complexity challenge. So functionality is increasing over time. The complexity of functionality is increasing over time, and therefore the complexity of verification of that functionality within the hardware is increasing. This is something we all accept, but bear in mind this diagram is not to scale, so it's only a representation of the challenge. So this is where we talk about our verification gap, and we're finding it difficult to complete everything we need to. So, but in recent years, the challenge and the complexity seems to increase more like this. This is how we feel as engineers. And so let me explain what these steps in the complexity are. So the first one might be ISO26262, which adds lots of effort and complexity to the process of verification. And ADAS advanced driving systems add highly complicated IPs to our microcontroller chips, and these require a different type of verification than traditional microcontrollers expected. Okay. And then along comes another standard soon, which will add even more complexity, I expect, to our the whole process of functional verification. Okay, so as we have quite a number of EDA vendors here today, I have some challenges for them. So this is our challenge as a verification engineer. So we use lots of EDA tools to complete our task. So let me continue. And so this is what I missed this point. Problem with animated slides. So the verification gap gets bigger and bigger, and this is our challenge to reduce that complexity so that we can manage it. So on to the challenges for our EDA vendors. So the first one might be controversial. Can our EDA vendors be slightly more proactive and come up with solutions more quickly? So ISO26262 was released in 2011, and it wasn't really until 2018 that we had working solutions for that standard. That's from a user point of view. We've had a new release of 26262, and along comes a new standard which will probably need new solutions, and I don't really want to be waiting for another 7 years for a solution to that, okay, as we'll be releasing products earlier than that. Okay, so next challenge. So one of the solutions that we have for 26262 is measuring diagnostic coverage and doing directed fault injection, that type of thing, so that you can determine if your product is safe. So yeah, so at the moment that's an add-on process that sits on top of functional verification. So at the moment we run our full functional verification, get all our code coverage, all our functional coverage, and then after that we run a directed fault injection flow which measures our diagnostic coverage for us. The question is why a more efficient way would be to measure that diagnostic coverage as part of function coverage, as part of our functional verification flow. So at the end of our flow could come code coverage, functional coverage, and diagnostic coverage would just fall at the end. That would be a nice thing. So that's a challenge to anyone here who could solve that solution problem. Okay. Big data. The problem is running lots of verification is you produce lots of coverage data, and this data becomes large very quickly. And in the world of using machine learning and to improve the efficiency of verification, we need to be able to store that coverage data over time as well as just for a single run. So we're talking about hundreds of gigabytes of data per IP, per run, per configuration. Yeah, so there's lots of data. It gradually gets quicker. So for machine learning, you need to be able to store it, access it, and visualize it. Okay. So tool qualification. So I've listened to various vendors talk about tool qualification last year at this conference, for instance. So as a user, we have to go through a whole process of making sure all the software tools that we use to verify our designs are safe, essentially. Do they cause errors in the design? Or will they allow bugs to get through? Or will they allow safety goals to be violated? So I think some of our tool vendors could do a little more, helping us as users to achieve this goal, rather than maybe state the only way to ensure that our simulator does what it says on the tin is to try your test bench in our competitor's simulator, because that's not exactly helping us as a user. Okay, so this comes down to the complex ADAS style functionality. So here we have radar data and camera interfaces coming into large processing units which process large amounts of data, and these need to this generates long tests. So a natural way to solve that problem is to run your tests on an emulator. So rather than in microcontrollers, our tests are generally in the minutes scale. With the complex large data sets, these become hours. Okay, 1 minute. I knew I was going to run out of time. Okay, so emulation is an obvious solution to bring that down to seconds. But the problem with emulation is we don't really get good functional coverage and code coverage. So that's the challenge on that front. I've gone the wrong way. I've gone completely the wrong way. I did. Okay, so there's a few challenges to tag on the end, but I've run out of time, haven't I?
Yeah, just put them up.
Okay, so we're looking at using machine learning for code coverage closure, how can we debug, maybe with potentially identifying buggy code, and ISO21434 brings along lots of new things that we're not entirely sure what they are yet, but maybe we could be using formal or machine learning for identifying vulnerabilities in our designs and various things.
Okay, thank you, Mark. Again, we've gone out of time for questions, but Mark...
And that's where I'm hoping to get to.
Yeah. All right.
To bring our diagram back. Yeah.
Normally we ask for 3 challenges, but obviously things are getting more challenging as time goes on, so maybe you have to ask for more challenges in the future. So a big thank you to Mark, and you're around a great Mark. Yeah?